Greetings everyone! Today I'm gonna do an in-depth review of the electronics found in the so-called SHEHDS 7x12 watt RGBW LED power that is sold on AliExpress for around 23 euros and all the other brands that sell this type of LED power under different names like UKing or without any brand label for roughly the same price. I will first go over the case, then the internal structure, followed by a quick analysis of the separate parts in the LED power. At the end, I will summarize the info I found out and will tell you what my opinion of this LED power is. Let's go! First of all, the power works. You connect it to power and the little fan starts whooshing around and you start seeing the light. It is, however, not clear to me which parameters influence the static color the power starts up with. The light, at first glance, is as expected for an RGBW LED power. The dimmer curve is surprisingly solid. There are visible jumps at the lower range of the spectrum, and there is almost no brightness difference visible between a DMX value of 200 and 255. But this is okay, and compared to other cheap Chinese lights, you can work with that. If you need visuals of the light output, there should be plenty on the internet. If this is not sufficient, I can provide you with some if you guys want. First, there is a power supply board. This outputs 24 volts and puts them into the dimmer board. The dimmer then takes this voltage, does some trickery and sends them off to the LEDs. While being at this, the dimmer also sends the 24 volts straight to the little case fan, which is very loud but unfortunately necessary to cool everything down. The LEDs themselves are mounted on a custom-made aluminum PCB, which acts as a rudimentary heatsink. Now to the hardware. The casing is cheaply made via injection molding and most probably consists of polypropylene. Here you can see the quality of injection molding they used. It is an achievement how bad this mold looks. I am located inside of the EU. Thus, they put a lovely shiny sticker on the power. But that does mean absolutely nothing, since those stickers aren't even allowed. There is an interesting sticker on the side with a strange QR code on it. Oh, and of course there's wrong information on the sticker because, yeah, why not? Also, the positives, they list the full company name and address, which is required inside of the EU. The metal brackets can be used to let the power stand on the ground or to mount it on a truss or a T-bar. However, since they are made out of 1 mm thick or rather thin steel, I would not hang this over anyone. These are not very confidence-inspiring. The screws with which they are attached to the power are also very flimsy. And well, yeah, you get the point, don't hang them. On the ground, the case does its job in the sense that you won't get shocked when you touch it. But as everyone in the field knows, things happen and people will stumble across them, fall on top of them, kick them and whatnot. The case will not protect against any of that. Also, there is no water resistance. The front plate is made of the same steel as the brackets and it looks okay when you don't look that close. Lastly, let's focus on the fan. It is very loud. With a 12-volt step-down converter costing $1, one could silence it while still keeping it running. That is $1 saved at the wrong place. Now let's go this chain backwards and first look at the LEDs. They are RGBW LEDs as promised, but this is no surprise. Without a lens, they do have a very big beam angle, but these lenses do work as advertised, and they produce a roughly 25-degree beam angle. I measured this at 1.6 meter distance. The light has a diameter of 1.4 meters, which leads to a 23-degree angle. This is as promised. At least ignoring the promise of the sticker. Now to the shocking part. These LEDs are actually 12-watt RGBW LEDs. When supplying the board with the max safe voltage for red, green, blue and white, which should be in the neighborhood of 2 volts, 3.6 volts, 3.6 volts and 3.6 volts, times the LED count, the system draws 83.6 watts, which divided by 7 is 11.9 watts, and thus almost the advertised 12 watts. They have a nice light output at that power, but get very hot. I added an old CPU cooler to the back, and this does wonders to the temperature. The big takeaway here is that they did not, strictly speaking, lie about the LED power, which I would have expected honestly. But that does not mean that they didn't at least deliberately mislead about the power of the power. Under full load, so R, G, B and W set to a value of 255, the whole power only draws 27 watts. That is a third of the advertised LED power. Something seems slightly off. To make things short, the LEDs are driven not at their max power, but rather at a lower voltage, likely to save power, produce less heat and save cost, because driving them at lower voltages means that all the components can be of lower quality as well. Then I proceeded to form an extravagant and crazily intelligent measurement procedure. First, I measured the voltage at a DMX value of 255, and then the current at the same value. U times I equals P, so I concluded that the LEDs get 11.9 watts in total. Okay. No. You got me? There is an error. Strangely, measuring the voltage that the dimmer puts towards the LEDs and the power that flows don't match. For example, red measures a voltage of 13.4 volts and a current of 222 milliamps. When supplying the LEDs with 13.4 volts from my lab bench power supply, it measured only 95 milliamps. 14.7 were necessary to reach the measured current of 222. This leads me to believe that the dimmer uses a PWM method of dimming the LEDs, and my Fluke multimeter got thrown off because of that. So take all the following measurements with a pinch of salt. I think that the current measurement is more accurate than the voltage one. Thus, I define the actual voltage that the LEDs run with to be the voltage that is necessary to reach the measured current. The new measurement procedure thus goes as follows. First, measure the current at 255. Second, connect the lab bench power supply to the LEDs. Third, set current and read the voltage. And last, U times I equals P, and there we go. The actual power of the LEDs are, drumroll please, 12.8 watts. That is not that much better. Keep in mind that this is the total power and not per LED. This means that every LED only uses 1.8 watts. That is bad. To be fair to the designers, there could be an error to this measurement, but I'm quite certain that it is not that off. But that immediately leads us to the sad tale of inefficiencies. I just stated that the max power draw of the system was 27 watts, and now I measured the power draw of the LEDs to be 12.8 watts. Where does the difference come from? Yep, that is the dirty little secret of the cheapest of the cheap power modules and dimmer boards. They are inefficient. 1/3 of the wall power is being wasted in the dimmer, and the PSU wastes a quarter. That is how you get from 80 watts advertised to 27 watts wall power and to 12 watts actual light power. In their defense, when putting the full power into these LEDs, they waste almost everything, so they may be driven at their max efficiency, but not their max power. But regardless of efficiency, increasing the power increases the brightness, and that is the thing we want. And even though driving an LED at 16% of its max power does not mean it only having 16% of its maximum possible brightness, it still is darker than it could have been, and most importantly, than implied. By the way, as stated, the max voltage of the power supply board is 24 volts. The voltage required to run the LEDs at max power is 25 volts. And this only holds true if the dimmer were to be 100% efficient. This PSU is by design not able to reach the max power, just because of its output voltage. But I also would not trust it to deliver 80 watts anyway. This discrepancy between the advertised theoretical max power and actual power is present in the whole industry, and for me a huge pain. I want to reiterate that. This is present almost everywhere they give the max power of the LEDs and drive them lower. However, I never encountered a case where the difference is so giant. This is where the Chinese OEMs lie to you. Unfortunately, I'm not an electrical engineer. I am an engineer and am specialized in a field related, but I don't possess anywhere enough understanding to reverse engineer these boards to a full extent and to quantify their rubbishness. Thus, this is how deep I can go. Sorry if you expected more. Now let's do a small excursus to electrical basics. Don't worry, it's not that hard. Answer me the following simple question. When you got a red and a black cable, which one is plus and which one is minus? If you ever used a multimeter, this is crystal clear. Red is positive and black is negative. This is common knowledge. In the same way, the VDI norms in Germany are not laws, but are treated as such. This is not strictly speaking a law. But you better follow this rule, if not, everyone will awkwardly look at you in silence while they slowly walk backwards. Now let's look at our culprit. Don't worry, there was a little white plug present, but I removed it for the ease of testing. What do you see there? The red cable is on top and the black on the bottom. This is the correct polarity. Above the plug there is a small plus and a small minus, the plus being below the minus. Now look closely where the red and black cables are. Yikes! This, by the way, is also the reason why there is a resistor unceremoniously soldered to the dimmer board. Naively as I were, I just connected the external PSU to the dimmer, red to plus, black to minus, without realizing that they did this objectively wrong. And well, some magic smoke later, and I had to replace this resistor, which burned away. Just for your information, there is seemingly no reverse voltage protection. Now we know. And while we are at it, the leads going from the dimmer board to the LED board are color-coded. Yellow, blue, green, black and red. This is very handy, since just from looking at the leads, we know to which color they lead. Yellow is common plus, blue is blue, green is red, black is white and red is green. Very straightforward. Very straightforward indeed. That cable tie, by the way, is my highly professional way of attaching the heatsink on the bottom to the PCB. But to summarize, these are all signs of cheaping out. I mean, they did not even bother to color match the cables they already bought to the LED color. This leads me to the wrap-up. How is this LED par? On the plus side, the unit works. Just barely, mind you, but it works. The LEDs are 7 × 12 watt, and the unit doesn't present an immediate fire and health hazard. And that for the low price of roughly 20 euros when on sale. But the con list is unfortunately very long. Starting at the noise level, the missing certifications, the shitty case, flimsy cables and the rubbish metal brackets. The LEDs are driven at 16% of their rated power, the PSU is not capable of delivering the required voltage and thus power, and the dimmer is not capable of that either. So where does this leave us? SHEHDS, Buking, and how they are called, deliver a working LED power for very cheap. It is almost as bright as my €90 expensive 5x8 watt LED power made by Thomann, a German direct importer and huge reseller or seller of stage equipment. But while this imported Thomann power is made with a stiff metal casing, trustable metal mounting brackets, rubber feet, comes with a 3-year warranty, is backed by a huge company which is famous for its customer service, has all the certifications, an actual working sound to light mode, a plug to loop through power, and a quiet fan, it still costs almost 4 times as much as the SHEHDS one. I would never use this no-name LED power as it comes. I just have too little trust in the PSU and it is too loud. But what this thing is great for is a starting ground for your own projects. Remove the PSU and buy a 90% efficiency one from Meanwell for €15. And you are safe in that regard. Then purchase a $1 to $2 step-down converter to get the fan silent, or better, a temperature controller. They don't cost that much more. If you are like me, you probably got some heatsinks laying around from old PCs and other things you took apart. If not, you can buy them cheaply too. They can help with the heat dissipation problem. This would leave you with a power that is not that bright, but is colorful, cheap, and relatively safe. And the bad case would be negated by buying old Power 56 with incandescent light bulbs and then putting the new PSU, the old dimmer, the fan, the LED plate into the old metal casing and running it like that. Oh, and one last thing, I almost forgot. Please, replace the horrible power cable. The one that comes with it is so flimsy that it is not even funny. If you don't trust yourself to change a power cable, you should not buy this power. Lastly, if you are feeling generous, you could also buy a DMX 4-channel dimmer board of AliExpress for around $14. But then, slowly but surely, we get close to the €90 brand import price. How you ultimately decide is up to you, in my opinion. They are an okayish basis to build upon, but not usable as they are. But you may decide differently. Thank you for listening and see you in the next review.